Hi, my dear students in grade 6. Today we are going to make our mathematics exam review worksheet semester 1. In this, we are going to solve together problems related to the topics that we have covered during semester 1. Please have fun, and things are really very easy if you use the rules that we studied together. Okay, concentrate, be ready, and let's start. Question number 1. Indicate whether the following statements are true or false. It's really very important that we read the given information well, we think a little bit about it, and then we decide whether the statement is true or false. 4 and 9 are prime numbers. This is for sure. It's not true, it's false. Why? Because 4 and 9 are both composite numbers. 4 has more than divisors more than 1 and itself, and 9 has divisors more than 1 and itself. So they are composite and not prime. Concurrent lines have all points in common. This is also false because these are concurrent lines. They have only one point in common. So this is false. The GCD of 8 and 9 is equal to 1. We can see that 8 and 9 are called successive numbers, and we all know that any two successive numbers, their GCD is always 1, so this is true. The two operations plus and times have the same powers. This is for sure is false. Why? Because plus and times, they have different powers and not the same powers, and times is stronger than the plus. From a point to a line, we can draw many parallels. If we have a line and we have a point, from this point to this line, we can draw one and only one parallel passing through this point and parallel to the line. So we cannot draw many parallels. We can draw one and only one parallel. So this is false. Question number 2. Here in this question, we should find the answer directly without any calculation. Of course, we should say the reason to know the answer. 10 to the power 4, this is a power of 10, so there is no need to write its multiplication sentence. From the base 10, we take the 1, so we write the 1, and we add zeros near the 1 as the power, because the exponent is 4, so we add 4 zeros. 0 to the power 418. 0 to any power always gives me 0. Now 1 to the power 1974, also this is a rule. 1 to any power will always give me 1. Now 763 to the power 0, the answer is always 1. Why? Because when the power is 0, the answer is 1. 629 to the power 1, also this is a rule. Any number to the power 1 will give me the number itself, 629. Also, this is a power of 10, 10 to the power 0, so we take the 1 from the base. Because the exponent is 0, so we should not have to add any 0, so the answer is 1. Now 10 to the power 7, also we take from the base 1, and near the 1 we add 1, 2, 3, 4, 5, 6, 7 zeros. Now the LCM of 8 and 16. We can see that 8 and 16 are two multiples. 16 is a multiple of 8. When we have to find the LCM of two multiples, then the LCM will be the greatest number, which is 16. Now the GCD of 15 and 16, as we can see, 15 and 16 are two successive numbers, and always the GCD of any two successive numbers is 1. The GCD of 10 and 30. 10 is a divisor of 30. Because 10 is a divisor of 30, then the GCD is the smallest number, which is 10. The GCD of 6 and 7, also we can say that 6 and 7 are two successive numbers. The GCD of any two successive numbers is always 1. Question number 3. we should observe the figures well, then answer using parallel, perpendicular, or concurrent. If we look at this figure, we can see a rectangle here. So this geometrical figure is a rectangle. In a rectangle, we have opposite sides. This side and this side are opposites, and this side and this side are opposites. So the opposite sides in a rectangle are parallel. The diagonals are, in a rectangle, these are the diagonals. This line and this line are diagonals. We can see that in a rectangle, the diagonals are concurrent. Concurrent means they intersect in a point. The adjacent sides are, let's see adjacent sides. This side and this side are adjacent. So the adjacent sides, because in between the angle is 90, the adjacent sides are perpendicular. In part B, we should draw two parallel lines D and D prime at a distance of 2 centimeters. So we draw the first line D, and we should draw the parallel D prime. How can we draw D prime? To draw D prime, we take the set square and we put the set square on the line D, and we measure a distance of 2 centimeters away from D. So this is the first distance, which is 2 centimeters. Also, we draw another distance in the measure of 2 centimeters away from D, and now we join these 2 points to get D prime. So D prime is parallel to D. In this way, we draw two parallel lines. Now trace T such that T intersects D at M. So line T and D intersect at M. This is line T, this is line D, this is line D prime. They intersect at M. What do you notice? We notice that if we elongate T, it will also intersect D prime. So T will also intersect D prime because D and D prime are two parallel lines. So to draw two parallel lines, we draw the first line, then we use the set square to draw two distances of length 2 centimeters away from D. We join the distances to get line D prime. Also, if T intersects D, then line T intersects D prime because D and D prime are two parallel lines, and this is a rule. Question number 4. We should decompose the numbers using powers of 10 and of course powers of 1 over 10. Now we have the number 4196082. This number is a whole number, so we start decomposing from the digit which is the ones. In decomposition or writing a number in expanded form, we should multiply each number according to the power of 10 that represents the unit. Always the ones is represented by the power of 10, 10 to the power 0. The tens is represented by the power of 10, 10 to the power 1. The hundreds is represented by the power of 10, 10 squared, and so on. So 2 we multiply it by 10 to the power 0, plus 8 is multiplied by 10 to the power 1, plus 0 times 10 to the power 2, the hundreds, plus 6 times 10 to the power 3, plus 9 times 10 to the power 4, plus 1 times 10 to the power 5, plus 4 times 10 to the power 6. Now, if we look at this number, we can see that this number is a decimal number because it has a point. In a decimal number, we have two parts. We have the whole part and we have the decimal part. So we should start decomposing the whole part starting from the ones. Also, we start 6 times 10 to the power 0, plus the 3 times 10 to the power 1, plus 7 times 10 to the power 2. When we finish the whole part, we should move to the decimal part. We start from the near the point we have the tenth. So near the point we have the tenth. Because we have a decimal part, we should write a fraction of power of 10, 5 over 10 to the power 1, because 1 over 10 to the power 1 represents the tenth. In the hundredth we have 0. It's not necessary to write the hundredth. In the thousandth we have 9, so we write 9 over 10 to the power 3. In the third number, it's also a decimal number. We should start with the whole part, but because the whole part is 0, so it's not necessary to write the whole part. We should start with the second part, which is the decimal part, also from the tenth of 0. So we start with the hundredth. We write 8 over 10 squared plus 3 over 10 to the power 3. In question number 5, we are given two numbers, 120 and 144. Using the method of prime factorization, we should find the LCM of 120, 144, GCD of 120 and 144. We should make the prime factorization of the number 120. How can we make the prime factorization? We should see if we can divide the number 120 by 2. We look at the ones, because the ones is even, so we can divide it by 2 and the answer is 60. Also, we should see if we can divide 60 by 2. Yes, because the ones is even, so we divide by 2, the answer is 30. 30 can also be divided by 2, the answer is 15. Now 15, we can't divide by 2, we move to 3. If we add 1 plus 5, it's 6. 6 is a multiple of 3, so we can divide 15 by 3, the answer is 5. 5 is a prime number, it can only be divided by 5. When the answer of division is 1, we stop. These are the prime factors of 120. So we write 120 equal 2 times 2 times 2 times 3 times 5. These are the prime factors of 120. Now let's find the prime factors of 144. Also, we can see that 144 can be divided by 2. The answer is 72. If you don't know directly the answer, you can make division. You can make 144 divided by 2 to get the quotient here. Now also 72 can divide it by 2. 72 divided by 2 is 36. Also 36 can be divided by 2. The answer is 18. 18 can be divided by 2. The answer is 9. 9 can be divided by 3. It cannot be divided by 2. The answer is 3. 3 is only divided by 3. The answer is 1. So these are the prime factors of 144. So if we want to write 144 as a product of prime factors, we have 2, 1, 2, 3, 4 times. So we multiply 2 by itself 4 times, and we have a 3 2 times. These are the prime factors of 144. Now to choose the LCM of two numbers by prime factorization, we should choose the more common prime factors. We have 2, 1, 2, 3 times, and we have 2, 1, 2, 3, 4 times. Who are more? 2, 4 times, so we take 2 times 2 times 2 times 2, 4 times. Now in 120 we have 3 1 time, and here we have 3 2 times. Who are more? 3 2 times, so we take 3 more 2 times. Now we can see in the tree of 120 that we have the prime factor 5, which is not found in 144. So for us, 5 is a not common prime factor. We take it in LCM. Now if I want to multiply and get the answer, it's very easy to multiply. 2 times 5, it's 10. Now we multiply. 3 times 3 is 9. 2 times 2 times 2 is 8. 8 times 9 is 72, times 10 is 720. See, it's very easy to perform our multiplication. Now we should find the GCD of 120 and 144. In GCD, we should choose the less common prime factors. If we have 2 3 times and 2 4 times, the less common is 2 3 times. If we have 3 1 time and 3 1 2 times, we take 3 1 time. 5 is not common, we don't take it in GCD. Now 2 times 2 is 4, times 2 is 8, 8 times 3 is 24. So the GCD of 120 and 144 is 24. Question number 6, we should perform different calculations. First, we have 2 to the power 5. Because this is a power, we should write it as a multiplication sentence. So we should multiply 2 by itself 5 times. The answer is 32. 9 squared, also we should multiply 9 by itself 2 times. The answer is 81. 300 cubed, we should multiply 300 by itself 3 times because we have cubed. Now 3 times 3 is 9, times 3 is 27. Now we count the number of zeros. We can see that we have 6 zeros, 4, 5, 6 zeros. We add them. 75 times 10 to the power 4. If we multiply a whole number by a power of 4, the whole number stays as it is and we add zeros as the power. 600 times 10 to the power 0, the number stays as it is and we should add 0 zeros, so no 0. Now we are multiplying a decimal number by a power of 10. So we move the point to the right because we are multiplying as the power. So if you move the point to the right, the answer is 4172.6. Now in this number, we should move the point to the right 5 digits. We move it 1, 2, 3, 4, 5. The point will fly and the answer is 875. 63.072 times 10 to the power 6. We should move the point to the right 6 digits. 1, 2, 3. It will fly and we add 3 zeros. So 63072 and we add 1, 2, 3 zeros. 31.79 times 10 to the power 0. Here, because the power is 0, so we should not move the point anywhere. So it's 31.79. As if we are multiplying this decimal number by 1, because 10 to the power 0 is 1. Now 897 times 1 over 10 squared. Because we are multiplying by a fraction of power of 10. Now we should move the point here because it's a whole number. So the point is before all the digits. We should move it to the left as the exponent of power of 10. So it will be 8.97. 74.9 times 10 to the power 4. So we should move it to the left 4 digits. It will be 0.00749. Now 23.51 times 1 over 10 to the power 0. Because the power is 0, so don't move the point anywhere. It's 23.51. We continue our calculation. Now here in these numerical expressions, we should apply rules of order of operations. In this numerical expression, we have plus and we have minus. Plus and minus are of the same power, so we should start from left. 9 plus 5 is 14. So 14 minus 7, it's a simple numerical expression. The answer is 7. 48 divided by 8 times 5 divided by 3 times 7. In this numerical expression, we have division and multiplication. Same power, we start from left. 48 divided by 8, it's 6 times 5 divided 3 times 7. Also same power, we start from left. 6 times 5 is 30. 30 divided 3 times 7. Now 30 divided 3 from left is 10. 10 times 7 is equal to 70. 63 divided 9 plus 5 minus 2 times 2 plus 5. Here we have operations of different powers. Who is the strongest? Division and multiplication. When we have division and multiplication, we start with the first one that comes from left. 63 divided by 9 is 7. 7 plus 5 minus 2 times 2 plus 5. Also we have multiplication is the strongest, so we get rid of the multiplication. 7 plus 5 minus 2 times 2 is 4 plus 5 equal. Now we have plus and minus. We start from left. 7 plus 5 is 12 minus 4 plus 5 equal. Now 12 minus 4 is 8. 8 plus 5 is equal to 13. Now we have parentheses. We know that parentheses is the strongest, so we should start with the parentheses first. We write 7 times 3 minus. What's 5 plus 6? It's 11 minus 2 equal. Now multiplication is the strongest. 7 times 3 is 21 minus 11 minus 2 equal. 21 minus 11 is 10. 10 minus 2 is equal to 8 because it's a simple numerical expression. Here we have 3 parentheses. We don't get rid of these 3 parentheses in the same step, so we start from left. So first we have 4 times 3. 4 times 3 is 12 plus 2 plus 3 in a parenthesis minus 36 divided by 4 equal. We get rid of the second parenthesis. 12 plus 5 minus 36 divided by 4 equal. We get rid of this parenthesis, so we write 12 plus 5 minus 36 divided by 4 is 9. Now we have plus and minus. We start from left, so we have 12 plus 5 is 17 minus 9 is equal. 17 minus 9 is equal to 8. Now we have 2 cubed minus 6 plus 1. Now exponent is the strongest. Because exponent is the strongest, we start with the exponent. 2 cubed, it's 2 times 2 times 2, so the answer is 8 minus 6 plus 1. We have minus and plus, we start from left. 8 minus 6 is 2 plus 1 is equal to 3. Here we have exponent and parenthesis. Parenthesis is the strongest. So 10 to the power 1 minus 2 times 3 is 6 plus 3 to the power 0. Now we have two exponents. We start from left. 10 to the power 1 is 10 minus 6 plus 3 to the power 0. Here we have an exponent. So 10 minus 6 plus 3 to the power 0 is 1. Now minus and plus, we start from left. 10 minus 6 is 4 plus 1 is equal to 5. 36 divided by 3 squared plus 2. We have parentheses and exponent. Parentheses is the strongest. If we look inside the parentheses, we have division and exponent, so exponent is the strongest. So we write 36 divided by 3 squared is 3 times 3, which is 9, all of it squared. Now the parentheses, 36 divided by 9 is 4, so squared. 4 squared is 4 times 4, the answer is 16. Now 7 plus 3, all of it to the power 9. We start with the parentheses because it's the strongest. 7 plus 9 is 10, all of it to the power 9. It's a power of 10. We take 1 from the base and we add 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 5 squared times 9, we start with the exponent. What's 5 squared? It's 5 times 5, it's equal to 25. So 25 times 2, if we multiply, it's equal to 50. Okay, my dear students, if you follow rules, as I said, everything would really be easy. So take your time while solving, don't rush things, and follow all the rules. Thank you. Love you so much.